Hello, it's Keith from Kinvert, and in this video we're going to be talking about inverse functions, and one of the things we want to know is, can we find the inverse of this function? So first of all, remember that a function is basically, you have for a value of x, you have a single value of y. And so if you have a graph like this, it's fine for each value of x. Say here, you go up, you find your single point of y. And you can also have graphs that do this, right? This is fine because for each value of x, there's a single value of y. Now, if you have a function, or not a function, but something like this is not a function, and that's because if you go here or here, for example, you have more than one value of y for that value of x. So that is not a function. Now, what we're going to be dealing with is inverse functions. Note the name function. So if you draw something out that is a function, such as this sine wave, right? So you've got this, but now you flip it up and over. So let me just quick draw this here. You've got something like this, but when you take the inverse, it's now going to look, I'm probably drawing this the wrong way, but you can see that this is not a function. Okay, because we've got more than one y value for each x value. Okay, so that's important to know. So you need to know that your function you're taking the inverse of, you're finding the inverse function, it needs to be 1-to-1. So, for example, if it's increasing, it needs to always be increasing. If it's decreasing, it always needs to be decreasing, because if it decreases and then increases, that's not 1-to-1, right? Because there's more than one value, and when you flip this up and over, right, this is no longer going to be a function. So if it's increasing, it needs to always increase. This could work. If it's decreasing, it needs to always decrease. It can never double back up, because this is the point at which, when you flip this up and you find the inverse, it's not a function, because it has multiple values. So let's look at a few examples. I'll do the original function in light blue, so it looks like this, right? And then we'll do in orange the, let's see, so it starts at 3 and it goes up to about there, right? This one is a function. Now, it didn't go quite vertical, okay? This is a function. This one works out. These two are good. Right here, I'll call these example 1 or whatever. These two work out. So number 1 checks out. Let's draw another one in light blue. I will draw this, okay? Is this one going to work? Well, when we reflect it, this one is basically going to be the exact same thing, right? Imagine that I drew this perfectly straight line. The orange line is going to be directly over top of it, because it's just going to reflect about that green line, basically. And so this is example 2. This one works out, but once you start to draw something that has a curve in it, so for example this, and then you reflect it over here, this is going to end up down here as orange, right? And this one has problems because this is not a function. It has more than one y value for given x values. Does that make sense? So this is example number 3, we'll call it. 3 is not possible. You cannot do an inverse function because this original, this blue one, it is not 1-to-1. If you go horizontally, the same y value exists for 2 or more x values, and so this doesn't count. Again, right here, you've got a y value that is used again over here. Okay, and over here. So this one you cannot find the inverse of. So coming up, I'm going to make some more videos doing some actual examples of finding the inverse functions of some functions. So this is Keith from Kinvert. This is part of our online course for Pre Calculus and Algebra. Link in the description if you want to learn more about that. And yeah, we will see you in the next one. Bye-bye.